Start off, Richard. Tell us a little bit about the new custom ops API.
Yeah, let me share my screen.
I found like a murder area in MPK 17. Like,
I'm letting Richard do a little bit first while you're finding a room, Michael.
You have the like blur on Michael, so we didn't see the bodies.
oh yeah. That was intentional.
I cannot get my computer to connect to this room.
Michael, so are you ready?
Yes.
Okay, let's hop back to Michael So's topic.
Okay.
Okay, so we were talking about nested tensor, and we wanted to understand how nested tensor, how we would do like inference stuff with it. To set the context, I don't think this half we have any particular need to do inference with nested tensor. So this is mostly just making sure that we don't, that we have a good plan and that like things don't collide. Let me share my screen. So the basic issue is that for export, we are moving to pre-dispatch A10IR. And that implies that we will sort of see tensor subclasses in the trace graph, which we don't necessarily, or we need to deal with, basically. We need to figure out how we want to deal with. So naively, if you like sent that graph to C++ and tried to do something with it, it would both require that we have a C++ implementation of each sort of dispatched tensor subclass method. And it would require that any, sort of conforming backend have the concept of a tensor subclass and implement dynamic dispatch on that tensor subclass appropriately to those C++ operators. So that seems like a lot of work for everyone. It seems like a lot of work for the tensor subclass authors. It seems like a lot of work for the backend. So we decided yesterday in chat, what we would do is like trace through these in a post path that basically says we're going to trace into the tensor subclass after the fact, right? So the main thing I want to highlight here, which is this implies 3 requirements of tensor subclasses we want to use in production. And so people should be okay with these 3 requirements if we go with this approach. So one is that the implementation of the subclass operations needs to be backwards compatible, matching the standard we set for A10 ops generally. This comes from the requirement that we are exporting in pre-dispatch mode. So if we try to execute it later in pre-dispatch mode, it needs to do the same thing, right? Like this is not so bad because the schemas are obviously already fixed because they're A10 schemas. But basically you can't change the implementation of an operator in a backwards breaking way. Okay. Number 2 is subclass tensors must be serializable, and that serialized format must meet the backwards and forwards compatibility requirements of tensor serialization, right? So if I'm serializing my nested tensor, that format needs to be stable because it's going to go in the state dict, it's going to go in whatever, right? And then the third is like there's fake and metadata associated with subclass tensors. I actually don't know what our story is for handling that generally in PT2. With pre-dispatch IR, but we're going to need to figure that out. We're going to need to be able to serialize it. So these are the 3 things that seem like sort of non-obvious implications of like serializing a pre-dispatch IR that we will have to figure out. Thoughts? Yeah.
NYC.
Can you give a little bit more details on what you expect to see as backward compatibility here? Like which code has to be backward compatible? How do you package the subclass code? What are the implications here?
Right. I mean, so that's kind of, I alluded to tensors. So how do tensor serialization work? As you know, we use like persistent ID to customize how pickle works, and we have this like archive format. And we basically expect that if you load up a tensor, like a state dict including tensors, that you like have a new version of PyTorch, the state dict will continue to load properly. That's backwards compatibility. we need to expect the same thing for tensor subclasses.
But the tensor subclass code is not necessarily shipped with PyTorch, right?
So this is what we use in production. So tensor subclasses, obviously they're like open registration. Anyone can make a tensor subclass. That's fine. I'm talking about like something like nested tensor, FPA tensor that we actually intend to use widely and be part of our sort of like production infrastructure. Obviously, like if you're just a random tensor subclass, nobody cares, you know, what you do.
Yeah, no, but then is the conclusion here like we need backward compatibility? The version of the subclass used in prod in FB code has to be backward compatible.
At least the serialization part, yeah.
Okay. Yeah, it's not like a version that is frozen somewhere or, you know, whatever. It's the one in FB code
Correct.
main needs to be backward compatible.
So let me try to like
basically same story as tensors, right? Yeah.
put some more color on it, right? So like when you look at this pre-dispatch IR that is operating on tensor subclasses, you will see, you know, things like A10 ops on the tensor subclass, right? And so those A10 ops need to still work on, you know, subsequent things. There's something a little more important, which I actually want to ask the room about, which is when a tensor subclass adds extra API that isn't like just an A10 operator, like in dtensor, we had to do a bunch of that stuff. That stuff now constitutes API that also needs to be backwards compatible in the same sense.
I have a question about that. So dispatch-wise, how does that look? Does that go through the dispatcher, or is it like traced through as not an operator?
Brian, tell us more.
I think it's the second. It's basically like it's Python code. So dtensor has a method toLocal that's like fully implemented in Python. And today that's like directly proxied into the graph in Dynamo. And the implementation doesn't.
Wait, when you say directly proxied into the graph, what does that mean?
Like Dynamo produces a graph where there's like this toLocal Python function directly in the graph.
Yeah.
How does that work with A10IR if the A10IR does not have all A10 stuff?
Yeah, that's a good question. I think so. Today, pre-dispatch IR is basically like a bunch of A10 and then a very small number of non-A10 things that are mostly like AutoCast APIs or AutoGrad APIs. And how does that relate to stuff like toLocal from local? I'm not sure. Maybe the right thing to do is make those like custom dispatcher ops to make pre-dispatch happy. But at least the current state today is that they're just like blind Python functions that we like proxy into the graph in Dynamo and then like directly trace through during normal make effects.
Right. So I think that will, if we can trace through them soundly, then maybe that's fine, right? Like what we see at the end of like export is just whatever toLocal or from local the implementation was. And in that case, there's no need for backwards compatibility. If that's not like sound for some reason, then we need to, you know, put our kind of like Richard hat on and define it as a custom op. Cancel.
So is the use case here mainly on servers or edge devices? Like what's the motivation here?
Oh, both. I mean, like we export for both.
Okay. So I'm wondering like just because like backwards compatibility surfaces, serialization surfaces are like pretty hard to maintain. And I definitely like I want to like maybe we actually need this, like maybe I could be convinced of that, but I guess I want to provide some pushback on like can we serialize and like fewer layers of the stack, because it seems like we're like implementing serialization in like over
So
and
I
over
agree
in
with
different places.
Yeah, so I mean, this is kind of what this document, like I was like, it would be actually nice if we could like trace under the subclass, right? So when we got to serialization, we had no concept of subclassing anymore, right? It was just tensor operations, etc. I was variously convinced that this like doesn't really work if you also want to like trace with AutoGrad or whatever. So we had this long discussion about whether that's plausible or not. But I agree. Like, it would be nice if, for example, from the perspective of like an exported IR, tensor subclassing is not a concept. It's already been kind of like managed out of the stack, right? It's like it stays in Python basically. I
Yeah.
don't. Yeah.
Because like I guess like so like one other like serialization point which we've been investing a ton of work in and like seems way more robust to this stuff because we don't like tensor subclasses are gone by the time we reach there is the ABI compatible mode in AOT inductor, and that will give you something that has like a really small API surface, you know, just a handful of ops. It should be super robust.
Yeah.
We can handle that, and
So
we've already invested a lot of time in that. So like, why can't we just use that?
Oh, I mean, so we need to serialize, say, like the whole model. So that is then we need to AOT induct the whole model or whatever, you know, it has to kind of go through that whole system, which is a variant of like whole model compilation. I think if we can deliver that in like, you know, the time frame that we need, maybe that's plausible, but I don't know that we can commit to that.
But aren't we like simultaneously pushing for whole model compilation? It seems like we're already signing up for that for a lot of these production use cases.
Yeah. Oh, I just mean like, so okay, just as a basic example, if we want to export to do inference with MTIA, like what does that look like for the AOT inductor serialization?
In theory, you know, if we're using the like Trident MTIA stuff and like we could make that work, right?
So I think my take on this is there's a substantial amount of engineering. So you asked like, why can't we just do that? I feel like there's like a lot of like pieces that would need to work like all together in order for us to be able to do that. And we're sort of working toward them, but I don't know that we will like deliver them in the time frame that we need. So that's kind of my take on it.
Yeah, I guess like my initial take of like subclasses being backwards compatibility surface is like that's a terrible idea. And like in general, like just because there's so much Python there, it's like not like a way very well defined API.
Yeah, I kind of agree with that, but I also don't know. Like, so say you're using nested tensor, right?
Yeah,
it needs to be backwards compatible, right? Like, I mean, even if we don't do any of the serialization business, even if we're just using Python, like if someone writes a model using nested tensors, and then later, you know, they just use like the normal open source thing, right? Like, and then they later, you know, like upgrade PyTorch. I mean, that model still has to work, like, right? Even in the PyTorch, and even like the Python type environment. Yeah. So serialization puts like a finer point on it because we have to pick like a specific place to serialize. We don't have a lot of flexibility. But I mean, like, I think the basic, like, hey, it should be backwards compatible seems like not crazy. Sorry, Alban, I interrupted you.
Yeah, I think I definitely agree with you, Michael. And I think I 100% agree that if you run an A10 op on a nested tensor, it should always do the same thing. And, you know, if you have a nested tensor concept, and you know you use a brand new implementation, you should be able to create them the same way and use them in A10 ops the same way. The part that I'm not as clear about is when Brian was saying random ops on that tensor now become API surfaces. Like, I would agree with Jason, like a lot of the implementation details of the subclass, they should not leak.
Yeah.
So having A10 ops on the subclass BBC sounds fine. Having other surfaces BBC is, I think, trickier.
Yeah. I mean, if we can trace through them, then it's fine, right? We don't know that we called like X, Y, Z. Oh, sorry, Basil, were you saying something?
I was just, I mean, nested tensor should be backwards compatible as just like saying, you know, embedding should be backwards compatible or something, right?
But backwards compatible for the public API.
Yeah.
It's very different than if your implementation detail needs to be backward compatible.
Yeah.
That's right, but is from or to or whatever we were talking about, these like random Python, are those part of the public API?
Yes. Not the from local. Well, from local, I think I don't know. To be honest.
So the from local to local they basically become custom autograd functions, and so I guess like they are things that need to run above autograd, therefore they need to like be in the pre-dispatch graph.
I think the question was, are there public API of detensor or not? And I think there are an implementation detail today.
Like, can users call them, I guess, is the question.
It's Python, yes.
But I mean, should
Sorry.
Are they invited?
Yeah. Like, do we put an underscore there, or is it like, you know, like, should they
Yeah.
call them? I guess. I don't know. Can somebody answer this question? I can, or I cannot.
Well, I think today the Python, like the user facing Python APIs for some of these like subclasses, like the entire thing isn't user facing. Like a lot of these subclasses are like not BC just sort of inherently. For like things like nested tensor, like it's the Python API that's a BC surface today, not the pre-dispatch API. The pre-dispatch API is like intentionally like an implementation detail.
Oh, where are those different?
I mean, like when you go into like the tracing, like you could have things like torch functions on it. You could like the act of tracing is inlining through some stuff and not inlining through other stuff, and you end up getting sort of this like sort of hodgepodge API that's sort of cutting through the middle of the implementation.
Okay, yeah, makes sense. Okay, I want to go in order because we have been NYC Waldick.
Yeah, so sorry, question. We're talking about tracing through the tensor subclass for inference. Is that correct?
Both inference and training need to trace through stuff. So
okay, and the problem is like we're saying that the implementation of how tensor subclass handles like an operator like is going to be a BC surface if we trace through it.
If we don't trace through it, yeah.
If we don't trace through it.
Right, because then it's
trace. Sure, but if we trace through it, then is it fine?
It will not be part of the BC surface because the thing that you will be saving is just the implementation at the time of tracing.
Okay, so concrete, like as a proposal, like could we do something like for the inference? I see it in this document. Like, could we do something like trace through the tensor subclass implementation for inference and then worry about training later?
It doesn't get rid of the backwards compatibility thing because one of the intermediate stages that we will be serializing is the pre-dispatch IR.
Okay, so you still have a problem for.
Also, another thing is, yeah. Yeah, we should do the hands. Let's go.
Okay, I'm going to put my moderator hat on. So I think, Michael, there's a little bit of confusion in the room about what exactly is the reason for pre-dispatch export. So can you tell us a little bit about that?
Sure. So I think there are a couple reasons. One is for correctness. Sometimes we export a graph and then we later want to use like eager autograd, which means that we need to trace above the autograd key because no grad and whatever.
But tell me more about this. Why do I want to export a graph and then use eager autograd on it? Well, why don't I just use the
well, so if you are doing it within the context of say like APS or something, you want to essentially freeze the code at a particular point in time so that you can do recurrent training without worrying about sort of like Python BC issues. Because we're in this like kind of monorepo type situation. So the traditional method of doing this was using Torch package, but Torch package is like not what they want. they a lot of sebs. So they would prefer to use like a more structured representation for this. And so we've decided to give them pre-dispatch IR, which we will fit the sort of correctness criteria because it will preserve like gradness for grad manipulation, while at the same time like not referencing arbitrary Python code, but then they have to maintain, like police the boundary out. So that's the primary reason. The secondary reason is that pre-dispatch IR is like nicer to write FX passes against. So there have been a bunch of users like what's it called? Optimus, the ads like deeper passes porting are porting to pre-dispatch IR. Similarly, quantization wants support to pre-dispatch IR for transformations. So we like this like abstraction level for reasons I don't, admittedly fully understand, but everybody seems to be asking for the passes to be written against pre-dispatch IR. So that's what.
Okay, and so once again, I could say, well, why don't you just do this, in one go? Why do you have to export it out?
Yeah, so the reason you have to export it out is because, in these production systems, often there are multiple interacting subsystems that don't live on the same host. We might want to do some kinds of lowering, not on a GPU host, and to like tie up a GPU resource or whatever. So they want flexibility with regard to like where and when they do it. They don't want to be like, oh, because serialization has to happen in this instance, now this service, which may be unrelated to the lowering process, must perform it because we need to perform it before serialization. This introduces coupling in their systems that they don't want, so they were like, we need to be able to serialize it. Essentially, we want to have flexibility with regard to where we put optimization.
Okay.
Sorry, are you saying that, I just had a clarifying question on that. You're saying that like because the model pre-serialization like has coded in that it runs on CUDA, this is the thing that makes it problematic for like deciding where.
No, it's a more general thing. It's like when you first export, you're likely exporting in something as part of the training environment or as part of like a specific exporting environment. And then you have like a different system that goes in and optimizes the model, performs like physical and logical transformations. And then you also have a system that is doing lowering to a specific hardware that probably needs that hardware device for auto tuning or something. These are all different systems in our production setup because they're kind of decoupled because we kind of mix and match them. We might use GPU over here, we might use MTI over here, or whatever. And so they want like an intermediate representation that they can like put through these various pieces of the process. And if we have an intermediate representation, and they say, oh, we want to program against pre-dispatch IR, it means we have to serialize pre-dispatch IR. We could tell them no, like actually you have to work on like a desugared below autograd representation. Although that also doesn't work in all cases, so I don't know if that's really an option.
Okay, let's do hands. Jason?
Yeah, so I think like the idea of like using pre-dispatch IR for running passes like makes total sense to me because like there's a lot of ways that that's easier to work with. Creating it as a new serialization surface, I worry it'll just have the exact same problems as source package. Because what we're going to have is we're going to have like a lot of sort of arbitrary Python state getting included in this. And that arbitrary Python state isn't going to have a well-defined boundary. We're not going to have a good testing system like we do for A10 to ensure there's no BC changes. And so like someone's going to check in a change to some Python state that they don't realize is dependent on
Sorry, is there like what Python state do we trace over in pre-dispatch?
I mean, in pre-dispatch, like especially for things like custom ops, right? For custom ops, like we'll have Python-defined custom ops that might point to a Triton function, and that Triton function will reference some globals in some Python module somewhere. And like if
custom ops, I think that's reasonable.
Yeah,
or like that is an issue. Yeah.
And I think tensor subclasses have a lot of similar issues to custom ops, in the sense that tensor subclasses are implemented in Python, and they when you sort of lower it, like maybe the methods on it will change, maybe the state will change. Basically you get this sort of slippery slope of sort of like once you introduce a little bit of Python state, you sort of like pull in all of Python. Just because it's sort of how flexible Python is, it's really hard to sort of draw a boundary that says like, okay, you have like a little bit of Python, but not a lot of Python, and so on. And so I feel like there's the user-facing Python API is a BC surface because like that's what our users write models in, and our user code needs to continue to work in the future. And sort of the post-dispatch IR is a BC surface because that's A10, and we have a lot of really strict, rigorous testing to make sure that that stays the same. And the AOT inductor generated binaries are a BC surface because we were putting in all this work to make them sort of ABI compatible, where like a binary generated with one version of PyTorch can run in a different version of PyTorch. And like, I think that those 3 really good BC surfaces should be enough, and I don't think we need a 4th one.
So let me try to propose a compromise here. So I think it's pretty clear that we shouldn't allow arbitrary tensor subclasses to go in the pre-dispatch serialization format. Michael, so would you agree with this?
Yeah, I mean, unless they affirm that they're backwards compatible.
Okay, so but now let's say, but you know, D tensor seems pretty important, right? Like, you know, it seems like we could, you know, be like, oh yeah, D tensor is very important, and we care about. Well, I don't even know if we care about exporting pre-dispatch D tensor stuff, but we could be like, we care enough about it. We own the code. It's all in PyTorch. Like, you know, it's kind of like adding a few more A10 functions in PyTorch. Like, we're controlling this. We know what the requirements are, and we can consent to signing up for BC. Because, like, you know, if nested tensor had been implemented as a C++ subclass, we wouldn't be having this conversation because there would have just been a bunch of A10 ops that do the stuff you need. And, like, you know, pre-dispatch would have grabbed them directly.
Yeah. I mean, I think that's reasonable. I also, so this is like to something, like even if we do sort of post-dispatch serialization, like the Python custom op thing is still a problem, right? Like it's just a custom op. So like you can always reference Python. Like to some extent, it's not that clean of a cut, right? Like we have Python in the system. We keep introducing new ways to jam it in there.
You do have stuff like autograd functions, which will go away. And autograd functions can contain a Python state.
Yeah.
So Jansel, so what do you think?
I think I just said what I think previously about what.
So you disagree with my compromise statement, like?
Oh, I think I agree with you that there's gonna be this slippery slope, right? Like, you know, some model, you know, you're gonna have one tensor subclass and then another tensor subclass and then another tensor subclass, and then like, oh, someone needs an autograd function, and so you're gonna and you're basically like sort of inherently pre-dispatch IR is full of Python blobs. And there's like lots of sort of ways that you can like jam Python blobs into pre-dispatch IR. And this is why we can never functionalize pre-dispatch IR. Like functionalization of pre-dispatch IR is always going to be sort of like partial functionalization because it's just chock full of Python blobs. And just it's sort of inherently, you know, that's the nature of it. And so for custom ops, like we can have a much more regular representation of custom ops lower down. Like by the time you get to ANP inductor, like all the custom ops are gone.
Wait, what? Why?
Because they're not all the Python parts of them. Like for example, if you have like an arbitrary user defined Trident kernel, in sort of every layer of the stack above, the user-defined Trident kernel is sort of Python-y. But by the time you hit AOT inductor, it's just PTX.
I don't think that has to be true for the user-defined Trident. Like, I think we can, like, if we just, like, you know, inline the string and things like that, I don't think it's a untenable problem for user-defined Trident kernel.
Yeah. I think it's probably like reasonably solvable at like the A10 level, but like for things like or like the post dispatch A10, but you know, for things like autograd functions or context.
Yeah, but Jason, I guess my question, like, I don't really hear a solution to the problem, which is that we need to serialize things correctly in the presence of autograd, and we need to serialize things so that downstream things that expect pre-dispatch IR can get pre-dispatch IR. Like, how do we solve that problem?
What I'm saying is like we have three serialization formats today, and we should invest in making those three serialization formats robust to these new concepts that we're introducing and new concepts we want to use. And for some of them, we should sort of say, like I think there's a lot of deficiencies with our current three serialization formats, and adding a fourth serialization format is just going to make this problem worse. Because now we're going to have four serialization formats that we need to like. If I want to, like, for example, like the new custom op stuff that Richard is adding, I think probably the right solution for that is to just say, like, no, you're not allowed to serialize it at these points, because
right. But once again, like, so for example, just like as a very basic example, autograd. I want to serialize autograd correctly so that I can later do eager autograd on it. I need like a way to do that. So we can say no, but then we just don't have a way to.
I think it's the Python API. I think it's the we should make the Python.
That, I mean, but that we can tell them they had to use Python, but like this doesn't help because they can't.
Ed, I'm curious if a refinement on your proposal could be that the BC surface is not the subclass, but a collection of ethanops. And one of these ethanops is create a nested tensor that returns a tensor-like object. We don't care what it is. It will be plumbed into, another ethanop that handle that object. And so the BC surfaces are just factory functions, and any implementation need to keep working. And that is part of our current IR specification that ethanops should continue behaving. The fact that a subclass is used, whether it's a C++ subclass, a Python subclass, or whatever else, is an implementation detail of these ethanops.
Yeah, I don't know how to get Jansel on board. I'm certainly happy to accept your suggestion, Albin. One operational problem with doing it on dtensor is one of the early problems they ran into was that they needed arguments into their special ops that weren't expressible in JIT schema. It was dumb stuff like device mesh or whatever. I don't. Maybe Brian or Wenchow remembers.
Device mesh and placement are the two. Yeah, and that's basically the reason we do the weird proxy thing in Dynamo today.
But we could commit to unwinding, these two types. And, arguably, if you're going to sign up for BC Surface here, you have to do something about this. But I'm not sure this solves the fundamental problem Jansel has, which is, Jansel, I think if you could have your way, we would just not have pre-dispatch export IR at all. Is that right?
No, I think we should not serialize it. I think it should be an ephemeral thing that we can change freely and not sort of lock us down into BC. Or what we say is we make it very restricted such that basically if there's any Python state at all in it, it can't serialize.
Horace.
So I think if I were to I guess categorize Jansel's point, it's basically that we do have, I think, what I would call a disturbing amount of ephemeral state occurring during lowering, and a lot of these are resolved by us saying that our typical strategy with a lot of these things is we verify that it's handleable at the Python Dynamo layer, and then we just trace through it later with AOT autograd. So I think one example that Jason mentioned with for example, two cases at places I know we do this now are for autograd function. We do not at the Dynamo layer, we do not have the actual forward and backwards graph in the graph. We instead have pointers to some side table or something that we then call during AOT autograd tracing. And so Jason's point is that this is obviously unserializable, and it is possible to make this serializable, but it would require a decent amount more work. Another case is for the user-defined training kernel that Jason mentioned. We also do the same thing where we have a side table during Dynamo lowering. In this case, that goes all the way through AOT autograd lowering, and it is only during the actual inductor cogen that we look into the table, pull out the string, and then materialize it into some actual string format. And I think the way I would characterize like Jansel's argument is that it is better for us to be able to do these things for various reasons, as opposed to trying to like force serialization, basically pre AOT autograd. Is that like a accurate?
Yeah, I think there's accurate. There's lots of other examples of that too. Like, you know, if you have a register hook in your graph, you know, what
Yeah,
we do.
yeah. So yeah, like backwards hooks, things like that. I think are also probably on Jason's mind.
Yeah, we just like shove a Python lambda in the graph with a closure, and like that's all going to disappear in post grad. But it's like there's no way we're going to serialize that. It's like fundamentally unserialized.
But like I think I guess part of the thing I don't understand here is that I think in cases like the hooks, if you just assume that they're safe to trace through, this is not a problem, right? Like you can just trace through them at lowering time, or sorry, like at dynamo time, instead of needing to.
Which example are you talking about? Because like for example, the two local from local example Brian gave for autograd, we can't trace through them. Like we need to keep them because you're going to run eager autograd later.
Or I think like for all of these, like there are solutions, and I think like the natural solution to me is basically the one that Albin proposed, which is that we turn them into atonops, and you know you register in the graph somehow. I think Jason's argument would just be that like this is a lot of work to do to ensure that we can like everything we do pre-tracing slash like pre-compiled autograd, pre-AOT autograd is serializable, and he would argue that like it's not worth the investment.
NYC?
Yes. A quick question, Jason. I think you quickly mentioned that something about custom ops existing in the IR that we serialize. You know, when we're talking about someone writes a custom ops, let's say, you know, with Richard's new API of it's, you know, I have an implementation of that thing and I want Inductor to just ignore it and run my eager kernel because, you know, I wrote an implementation for it and there is no way Inductor is going to fuse anything with that. Was your take here that these things should not be in the IR or not allow serializing these kind of things, or did I misunderstood?
I think they should be in the IR, but they should not be serializable until after grad.
But there's still Python blobs after grad, right?
Yeah, even after grad. I think for a lot of these custom ops, we should just say like, sorry, you can't use export plus custom ops. Or like you need to do a bunch of extra work. Like you need to implement your custom ops in C and provide like a C.
Yeah. Okay.
Yeah.
But if we say that, you know, the custom op API provides you a way to say this is my C++ implementation of that, the CPU C++ implementation of that op, then that should be fine to export and then, you know, have the system use that.
Yeah.
Okay.
I think, but like I think like, you know, for open source users, like we should allow them to define custom ops entirely in Python. You know, those custom ops should be able to like manipulate global state in Python. And I think if someone tries to call export on that, we should just throw an error and just say like, you know, sorry, you can't use this. You can't export with
yeah.
this.
Okay, thank you.
Okay. I mean, I heard a lot. I think so. I heard various things. I heard that we think it's a lot of work to police the boundaries of yet another serialization format, which is pre-dispatch tracing. I don't understand. Like, I think the biggest problem I have is we have like some like user requirements. We need to meet the user requirements. Or we need to figure out how we can like not meet the user requirements and tell them to like take a hike. Or we have to do all this work. So I'm trying to understand like at what point do we need to commit to doing the work?
I definitely feel like we're in a disagree and commit situation, Jansel, where it's like, you know, you can tell us not to do it, and then people are going to do it anyway.
Or like, For sure.
in that I think I agree with Jansel. The part I don't get it, and why I was asking Michael about like the different places where this code is running is like, what if thought experiment? What if we lied and we're like, oh yeah, we're serializing, but like we're actually just running the Python again? Uh, where would this actually break? Like what part of the, you describe these various like things that are running on part of the whole system that are running on various things. Like what would actually break if we did this?
Well, I mean, I think that is equivalent to how we do torch package when we extern something, right? Where we're kind of like, we serialize, but we really don't. What we're going to do is reference it from the external environment, get it from Python, like, the Python world, and then use it in our package. And so I think we have like pretty good sort of empirical proof that this is like reliable.
Torch package has its own like.
Oh, but like morally, that's what you're talking about, right? It's like you poke a hole and you're like, okay, this part we're going to get from Python, like the outer Python state, not from our serialized package.
Yeah.
So
this proposal slowly just turns into Torch package 2.
Yeah, I mean, I think if we put in the work to say you can't like export any of these things that we think are not worth the risk, which I think we've identified some obvious ones, then I think that's way less bad. But yeah, I agree that it requires a lot of work to set up that boundary.
Like I think the reason why this discussion feels very like hard to come to a conclusion is basically like Jansel and me to some extent, like we give examples and then people come up with ways to solve those examples. But like the fundamental thing is not about like any particular feature. It's more like philosophically about whether we want to commit. Like, is it worth it to put in the effort to commit to resolving like A, B, C, D, and E that we have today in order to do export?
So my basic thought about this is that I think most of the examples you raised are areas of coupling that we will need to fix eventually, just like in order to make things work in our production system. And like whether we do them now or later, it's fine, but we will
I'm just gonna propose that we like talk separately where we go through like the actual like each individual item and like I actually go through like the effort required for each one, because I feel to me like that's like the main crux of the issue here, which is like how messy / hard is it to support these in the first place. Like some of these seem like manageable and they're just kind of like issues with how we've implemented today. Some of them, at least offhand to me, seem perhaps a little bit more intractable. I don't know if this just seems like punting the issue, but like I guess to me that feels like the.
Yeah, so I mean, I think it's fine to punt the issue because it's all sort of degrees of risk and degrees of like effort. I don't think that like our system is not well formed enough that we can actually declare a slice after which it's safe. Like we hook from every system into every other system directly, and that's fine. But like I said, like any time that we propose to use one system without using the others, which in production we do all the time, right? Like we might not use inductor, we might use TensorRT. They want to use TensorRT for like the Grace Hopper stuff. Like I don't know. I'm not going to tell ads they can't do that, right? Like so then they need a system that like works.
TensorRT also has a binary serialization format that we could ship. So like one thing we could say is like you gotta you do all your passes, you do all your compiling ahead of time. You get like a binary artifact, and then that binary artifact is like the main serialization surface.
Yeah, so my point is when you export, you typically export from a trainer. We have like separate tiers to do optimization because optimization can take many hours, etc. So, like that's another area where we use one part of the system and not the other parts. We do transformation separately from graph capture, right? These are like different stages in the system. And so that's why people want to use one without the other. And I think what we're discussing is how coupled should these systems be? right? Like, should we require that after some point in the process, you have to have like a structured contract for two of these things to talk so that we can serialize it and maintain backwards compatibility for it? How plausible is that even in the presence of all this Python running around? I think is one of the things that we're talking about. My claim is that like this is unavoidable. We will have to deal with this. Otherwise, like, I don't know, we're going to be in like a kind of torch packaging situation. And people will come to us and they'll be like, yeah, fix this problem, and then we'll just like fix it later.
Okay,
so
can we just examine
yeah.
the two like use cases Michael So gave us for pre-dispatch as a serialization format? So the first use case was I want to freeze some model code for recurring training, so that I don't have to pick up changes in the monorepo as people are working on stuff. Okay, so are we arguing, is camp we don't support pre-dispatch serialization arguing this is a bad thing to want, people shouldn't want this, or are we arguing there's another way you can get what you want here and it's blah?
I mean, so basically, like what I think like the true fix for this is, and like sort of the root cause of basically like all of these BC problems in FB code, are the fact that sort of we have this skew between model version and PyTorch version, and sort of PyTorch is sort of constantly changing under your feet, and that's sort of like an insane way to design software. Like we should, like, I think like the real fix is we should version PyTorch in FB code, and we should sort of through the sort of the lifetime of the model, we should couple the version of PyTorch and the version of the model. So in that case, serializing Python state is no problem because the Python state isn't changing out from underneath you. And so I think like, there's a few ways to accomplish this. Like one is we could have like major releases in FB code where, FB code is running on PyTorch 2.1, and, your model that was trained on 2.1 will always run on 2.1. And then, when you want to upgrade to 2.2, you have to there's some testing and verification that has to happen. So that's one way. The other way would be to bundle the code of PyTorch along with the model, and sort of like basically like sort of say like, okay, I'm gonna package the two together, and I'm never gonna sort of be swapping out PyTorch code from underneath models. And I think that would basically fix all of these this entire class of BC problems, and would be far more robust because it would be a much more well-defined BC surface.
Okay, just need someone to implement multi-version PyTorch in FB code.
Actually, Michael, curious what you take. Do you think that that's kind of the direction that the Python predictor is going?
No.
Or no? Okay.
No. So my issue with this is I think that it would solve this particular problem. I think, I don't think that it's correct to characterize it as an insane way to build software just because it has other benefits that we like. But the practical issue is like, we cannot make this decision, right? Like we, as PyTorch, this is not within our scope to change. So like either we can like, commit to trying to sort of change this wholesale and convince ads and convince MRS and convince FB code like dev infra and like do that. Or like we have to do something else. So like, while I kind of agree with you, actually, I strongly agree with you, Jason, that like your proposed setup would solve the backwards compatibility problem in this domain. It's just not going to happen unless we like commit a significant amount of resources and time. And even then, it's not going to happen for like 2 years. So like, what do we do? Right.
Hey, Michael, quick question. Like on the fair side, there's totally a standard practice of just bundling up all your stuff into a Conda environment.
Oh, but the difference is they don't get access to FB code stuff.
Yep.
Sure. But that doesn't necessarily mean that practice wouldn't transfer over. I'm not suggesting it. I'm just curious.
No, I mean, like I said, I kind of stipulate to the claim that like it would work if we did Conda. I think it would have other trade-offs. I think there are people who would argue that those other trade-offs are like sacrificing those other things is not worth solving this BC problem if it's just, you know, like if we could just solve this BC problem half-assedly, kind of like on our side. But my major thing is just the practical thing of like shipping that is not something we can do alone. It's not something that's within our ability to make a decision about, and it will take many years.
Okay.
All right, I want to examine the other use case as well. So this one was people want to write passes on pre-dispatch, but they can't do it all in one go. So are we going to argue that they should just do it all in one go, or do we have other options for them?
They should just do it all in one go.
Okay, so Michael, so tell us why they can't do it all in one go.
I mean, I think you, like, once again, you literally could do this. It's just like you had to re-architect the rest of the system. Right? Because, okay, so how does it work? We do in-train or publish. So the training system, after a given checkpoint, and we're like, we're done, we publish, right? And then typically we don't want to tie up the whole mass job, which is like 128 to whatever number thousand GPUs. And like, wait, so like, okay, we can, it's all changeable, right? Like we can say, at some point, actually, we make sure to new up the same version of Python so that we can kind of transfer things over nicely. And then we get on a single host and we do the export and all of our passes. It's just like, you know, when you talk about these scale production systems, all these teams are different teams. So they prefer to like work in their own system and operate via contracts with other systems.
I mean,
so like
couldn't you just like ahead of time compile everything at the very start? And then when the job is finished, you only export the weight, so you don't export the code?
Job is finished. You only export the weight. Yeah, plausibly. I mean, so actually, yeah, that's another way of structuring it. So you could say, okay, I'm gonna like export, and I'm going to house all of the optimization lowering in a single environment. Well, one is that there is no one environment that will be able to do all the lowerings that we want to do, right? Because like you might need different hardware. The other is the same like organizational thing of like we could create a big monolithic blob that just like does everything at once.
Hardware? Like we only have like 4 types of hardware. We could just export for the 4 and then
on the same host.
Yeah, just do it all ahead of time. Yeah.
On the same host, we need access to specific hardware in order to do like auto tuning or something, right? So like we need like a GPU to do GPU auto tuning. We need an MTI to do whatever the hell MTI is doing. Right, so there's like a little bit of, I mean, I think that's once again solvable. Like you could kind of make sure all the environments are the same between the different hosts and like create a little gang job to do the various export. And then it's just like a,
or you could, yeah, or you could just do the export on 4 different hosts, but like the weights format should be backwards compatible between all 4 because like the weights are all predetermined. So you
right, but like what do you pass to do the export on these different hosts, right? So then we have to decide this. So,
and the auto tuning needs real data, right? Like you can't auto tune with fake data, right?
I guess that's true too.
Currently, all of our auto tuning
I don't know
fake data.
Well, okay, so I mean, maybe you need real data, maybe you don't. So you know you can do it this way, and then you know once again, there's kind of the like organizational aspect of like we could kind of monolithically do this, but in general, would we like try to scale these teams? We don't. Anyway, all this by way of saying like. All of this is more work than what we're discussing, right? Like in absolute terms. So it's just a question of like, what do we like? Where do we want to pay, right? We have to pay either way to solve this problem. Yeah.
Any final comments? I don't think we've resolved this, but I guess we have the main point of contention, so we can keep arguing about this offline.
I've been arguing about this for like 5 years.
Oh, I'm sorry.
Okay, right. But what are we gonna do? Like, we need to decide on something.
Look, I'm telling you, Michael. Like, what's gonna happen is like ads is like we absolutely need this thing, and none of the alternatives actually are technically viable, and we end up in VC pre-dispatch world anyway. Like this,
Right,
this
so-
is my
so this is-
prediction for what's going to happen.
I think if that is the case, it is worth the effort to at least like explicitly enumerate
Yes.
the Python states cases that we have today at pre-dispatch.
This is the failure case that I want to avoid, where we say that we don't want to put in the work because there's a better solution, that lies somewhere else. We don't do that better solution, and instead we just like do a bad job with the thing that we are forced to do anyway, right? Like we need to do a good job, otherwise it's going to come back to bite us. Or we need to commit to not doing it and pushing back at the org level for a different solution.
I think doing this exercise is worth it regardless, simply because, as Jason mentioned, we have, I think, serializability issues at many layers of our stack, including post-dispatch IR. And I think it's worth enumerating the cases where it becomes unserializable there as well. I know of at least one, but...
NYC Nostrand, you still there? No? Okay. Thanks, everyone. See you all next week.